everybody, welcome to our next hackathon session. Today we have a very exciting topic, GraalVM native image and polyglot programming with Oleg Zelayev from the Oracle GraalVM team. Hi Oleg, it's good to have you here. How are you?
Hi Marcus. I'm pretty good, doing great. I'm very excited to be a part of the hackathon team, right? Hackathons are one of my favorite ways to, like, I never participate myself, right? Because I'm not disciplined enough, but they're one of my favorite ways to see people like try the new technologies, right? Like every time they build amazing apps and have great showcases, and I'm usually in the beginning, I'm like, oh no, there is plenty of time, and then by the end, I'm like just always in awe what other people have come up with. So I'm very excited for this one.
Yeah, great. And we are very excited to have you here because we believe that GraalVM is really a game changer in the Java world. And we believe this, every developer should know what GraalVM actually is, how it works, and what are the benefits are for the entire Java community. And so, yeah, let's get started. Oleg, the stage is yours.
Thank you very much. Let me quickly share my screen. I think you need to stop sharing yours, unfortunately, because that's how it works.
Now it should work.
Right. So you should see the hackathon homepage here. This is I hope for everyone who are present here, this would be like a homepage or at least an open tab for a few months now, right? And this is not the first session in the program, so I'm sure that you know all the details and all the organizational details about how to participate, where to find more content, where to find the previous sessions and everything. So I will just jump in and cover some information about GraalVM, so you have a better understanding how it can enhance your applications and maybe get more ideas what you can build for the hackathon here. So without further ado, let's have some slides here open. And this is a very, like, I would like this to be a very interactive and a little bit casual session, right? I don't want to make this a lecture where I kind of like impose my opinion about, like, or my thoughts about how GraalVM should be used or how it can, how you can like tweak or enhance your app with it, right? The hackathon is about the exploration of ideas. So I would like, if you have any questions, what I'm trying to say, if you have any questions, please go ahead and ask me or ask them in the chat. I'm sure someone will forward them to me, and as soon as you have them, right? Because the sooner you can interrupt me, the better will be the answer, most probably, because it will be timely. And if you wait until the end of the session for the questions, you will forget, or I will forget the context, or so it'll be less efficient. Right. So let's get started. This session, I would like to have an introduction to GraalVM technology. And my name is Oleg Zelayev, as Marcus introduced me. I'm a developer advocate on the GraalVM team at Oracle Labs at Oracle, and you can find me online. I know that there will be a further maybe Q&A session later, and I will be there as well to answer your questions or to help you with some issues. But if you just want, you can find me online all the time, right? Doesn't have to be a predefined time. So you have to understand that this is a technical presentation. So yeah, do not make any foregoing like business decisions about Oracle technology based on the contents of this. This is very important. I've been told, right? And also GraalVM native image, which is a part of the GraalVM technology. GraalVM native image is available under the early adopter technology. That doesn't mean that it's experimental. It's stable. It's mature. You can use it in production. What it means in the layman terms is that It could change from the release to release. So your code, you might need to like follow the releases and update it and so on, right? So be mindful of that. Let's get started with the technical bits, right? And these legalese can't be all that interesting. GraalVM is a high-performance polyglot embeddable virtual machine for a number of languages, right? There are three main adjectives, which is high-performance, polyglot, and embeddable. And GraalVM offers you in the runtime environment for a number of languages. We have currently the JVM languages, JavaScript, Python, WebAssembly, Ruby, R, and LLVM bitcode as the languages that the team provides. And there are also a Smalltalk dialect. There is also some custom languages. There are new language explorations happening on GraalVM from the community side. So you really can run a very diverse set of programs on GraalVM, and GraalVM offers you a runtime. And there are two promises that GraalVM tries to make. One is that your programs will run fast. So we are trying to build a high performance runtime that will enhance the performance of your applications. And the other one is its embeddability, right? So you can take the GraalVM technology and put it into your JVM based or native application and give it the ability to execute programs in the available languages as well, which opens you the door into a very vast set of use cases that normally you would not be able to achieve, or at least it will be much harder. So currently GraalVM offers three advantages for Java developers or for developers who use JVM languages. I will call all the JVM languages Java, right? Like for the simplicity, right? Do not, please do not get offended, right? Like it could be Scala, or you could be writing Kotlin, or you could be writing Groovy, right? Yeah, as long as it works on the JVM, right? We're going to call it like a Java application, even though the source language of that could be different. Say like a Java application would mean that it is a JVM bytecode application, right? When you compile and you get to a set of jar files, it doesn't really matter that much what was the source language. You can execute that on the JVM, so we'll call that a Java application. That is not, I'm pretty sure that is not the 100% approved term for that, but it's just for simplicity, I'm gonna do that. So for Java applications, GraalVM offers the high-performance optimizing JIT compiler, the just-in-time compiler, and this is probably the most straightforward application of GraalVM for Java applications. You can run them on GraalVM using the GraalVM in JIT mode, and then they will potentially run faster. It's a different technology. The just-in-time compiler is different from what you normally get when you download your OpenJDK binaries or some other JDK distribution. So when you run your code enough times, right, and some of the code becomes really hot and the VM figures out that, oh, I need to optimize this, then it gets to the JIT, and the better JIT can produce better machine code. Better machine code means that your programs are faster or more efficient in the resource, in how they use the resources, right, CPU and such. Then that is one thing. Then the GraalVM includes the native image technology, which can take your application and produce the platform-dependent, standalone, executable binary of that application. And this is a very interesting possibility that GraalVM, I think GraalVM popularized quite a bit since when we announced it like 2 years ago. So what it means that this result of this application, this resulting application, doesn't depend on the JVM, right? It's a platform binary. You can double click it and it will run. And it will also have the performance characteristics of the native applications. This is the second part. And we will spend a little bit more time on this today, because I think this is for the creators, for developers, right? This is a much more interesting functionality that GraalVM offers, because it's less transparent, right? Sometimes you need to tweak your application. Sometimes you need to understand the benefits and trade-offs a little bit better. So compared to just running on the faster runtime, this is more interesting and should offer more interest for the hackathon participants. And then there is the multilingual capabilities where you can run different languages inside the same process. So within your application, you can say like you have a Java application, and then you can add some JavaScript code in it, and it will execute within the Java process, and it will run, and it will get compiled as well, and it will run at a very decent performance speed. So you can mix and match, and that opens truly the largest ecosystem of software that you can get, right? So normally for a Java application, you would be limited to what's available on Maven Central, right? Because normally you consume dependencies which are Java applications as well, Java libraries, jar files. But with GraalVM, you can execute JavaScript, so you can use JavaScript libraries from the JavaScript ecosystem. You can run some Python, so you can execute some Python code, which might be very interesting for you if you're building something about that can use some machine learning or data science, right? The same with R, for example. R is a little bit more obscure language, but this is very, very excellent for data science, and very many teams use R for just wrangling the data and doing the statistical analysis on top of that and all of that. And so GraalVM offers those ecosystems to your applications. And this is one way. And then it also opens your ecosystem to the languages that you see there, right? So you can, if you have a library, say you offer some excellent functionality, maybe it's a data access library, maybe it's MicroStream, right? And you can package and you can use that from applications written in those other languages. So you can have a JavaScript application, maybe a Node.js application that can use MicroStream's functionality as if that would be like a JavaScript library. So if you're building libraries in Java, you can also expose them to the ecosystems of those other languages, which is a very interesting possibility for some use cases. So how do you get started with all this goodness? It's very simple, right? GraalVM is a runtime, so it's very similar to the JDK that you would normally download, right? So how to get started? You download the package, you download the GraalVM distribution, you unpack that archive that you have, and you put it to the path, right? So the GraalVM home directory that you get when you unpack the distribution contains a bunch of executables. One of them is a Java executable. So GraalVM contains a compatible JDK. Currently, we offer Java 8 and Java 11 based versions. In the future, we would like to get on par with the JDK versions that are released, but currently it's 8 and 11. And that would be very interesting to hear which version of Java you're actually using normally. But if it's 8 and 11, right, you just put it on the path, you run your Java application. That Java comes from the GraalVM distribution then, and it runs your application, and your application runs, and you're all set. Why would you want to do this? Let me actually show you. You can see here my, this is not excellent, right? You can see my command line utility here, right? And I would show you the HO GraalVM home. We can see this. Let me just show what's there. So I will go there, and I will go to the bin directory. And this is the Linux machine. So on macOS, you will have this macOS normal, like macOS home content or content home directory before you get to bin. But in the bin directory, you get your normal thing here. You have the JDK inside. So you have your Java command, and you have your Java C, and you have your Java P and whatever else you need there. This is a Java 11 based distribution. So you get the JLink and everything. You get JShell and so on. So you can use them, right? So when I do which Java, I get what? Let It's a link, supposed to be a link, right? When I do Java minus version, I get my GraalVM distribution here, and I'm using the GraalVM Enterprise Edition distribution, but it's functionally equivalent, and it can run the same applications that the GraalVM Community distribution can. So GraalVM Community Edition is an open source product, right? So it's built on the open source bits of GraalVM, which you can find on GitHub. The main repository for that is github.com/oracle/graal. And that is prepackaged, built, and that is the Community Edition. The GraalVM Enterprise Edition differentiates by having a proprietary GraalVM compiler in it, so its performance will be even better, and also some security and some other features to distinguish from the community. But they are functionally equivalent in the sense that they can run the same set of programs, so you can use whichever you want. GraalVM Enterprise Edition is available from the Oracle Technology Network. So if you go to the GraalVM downloads page, you can choose which version you want, and if you want to evaluate that, you can do that definitely with the Enterprise Edition as well. So that is all good, right? So I can run my Java here, and I can run my normal applications, right? And it's very simple. I'm going to show you some examples later, but you can just download it and run your Java. Right. Why would you want to do this? Very simple, because performance means money. There are a number of companies who are using GraalVM to run their applications in production right now. For example, Twitter is using the GraalVM compiler to run their Scala microservices, and they get really good results about that. The Oracle Cloud Infrastructure team migrated their, I think, monitoring services like sometime last year, I think, which feels like a like a very, very long time ago, right? But they migrated to GraalVM, and they saw improvements in the peak performance. They saw the decrease in the time spent during garbage collection. They migrated seamlessly without much issues. You can read about that in the blog there. But this is what we see GraalVM doing. It enhances performance of your applications, and we know that because we run a ton of benchmarks, right, on every release, and we just see that GraalVM shows better and better results. And it's like one important bit, it keeps getting better as well, right? So just recently we released 20.3, the last release of 2020 for GraalVM, and we run the benchmarks, and we run the last year GraalVM on the same benchmarks compared to the current release. I'm sorry. And yeah, we like there is a 6% improvement on average for the metrics between the last release and this release. So that's in 1 year. Doesn't seem like very much, but it accumulates, right? And given that it was like the state-of-the-art result last year, it's improving on the best rather than improving from the position of having a very lousy baseline. So this is just performance. This is just running your Java application. So if you're building something for the hackathon, if you're building something with Helidon and MicroStream, and it's a Java application, you can just run it on GraalVM, measure performance, and have some stats maybe in the presentation about whether GraalVM improves it and by how much. And we'll be very interested to see that. However, I might agree, I have to agree, this is a little bit boring, right? Performance is very important in the real world, but it's sort of something that they take for granted, right? You never actually, like, it's not a groundbreaking feature that you develop, right? It might be when it gets to the point that performance is so good that it enables some new use cases that weren't possible before. But normally, if it's just, oh, it runs like 20% faster, so my cloud bill is smaller, that might not be the most exciting result even though it's very useful in the real world. So you are welcome to run your applications on GraalVM that you create during the hackathon. But maybe if you want to really explore the possibilities and explore the new, then you should concentrate maybe on other aspects of how GraalVM can help. Though I have to also agree that there is nothing wrong with having better performance. So let's talk about performance from a different angle, right? Remember I said that GraalVM can offer you the native compilation technology called native image, where you take your application, you build it into the standalone executable. And this is specifically very interesting for cloud deployments. Why? Because in the cloud, we normally run our applications in a small, tiny, very constrained environments where we pay for the compute resources that we use. So if you can put your application into a smaller environment, you will pay much, much less. And if your application performance metrics are a certain way, then you can use cloud way more efficiently. Specifically, if we talk about like those very small containers and offerings like serverless and function as a service platforms, where you want to slice your code as thin as possible, deploy every individual unit standalone, get the cloud to manage all this setup, and then pay only for the resources that you use. It doesn't make sense often to use technology that is concentrating on the peak throughput, right? In the cloud, the performance metrics that we are trying to optimize for normally are not the peak throughput or the latencies that we are typically optimizing for when we write Java applications. So in the cloud, we more and more see the importance of the startup and the lower memory footprint, and also the smaller packaging, because we would like some orchestrating platform to manage our deployment for us. And that will mean that we would like to treat our applications truly like a cattle, right? We would like to auto-scale our deployments based on some metrics that we might not even know, right? So if the cloud decides that we need more instances of particular applications, it will create them, or it will scale them to 0, all in the effort to minimize the costs that you're trying to, that you're paying to the cloud provider. So for that, you need startup speed because you want to auto-scale, and you want the lower memory footprint because you want to auto-scale those smaller containers. Can someone tell me, is my video lagging behind or not? Because I see myself lagging behind there very much, but from the audio, but I'm not sure. So you can type it in chat. That will also tell me that you're still following, which would be very nice. Right, so let's not distract ourselves further by that. Right, metrics, performance metrics. So GraalVM offers you 2 modes to run your applications. One is a JIT, one is ahead of time compiled, and they very naturally map into those axes of performance that we see, right? So if we want peak throughput or the best maximum latency, JIT it is. But if we want to optimize for the cloud, we should explore the ahead of time compilation facilities that GraalVM offers. Luckily, they're both, so you don't have to switch your technology or the language or that you're using, because you can just switch the runtime. In the JIT mode, you just run your application normally with the Java utility, and you run your classes, and it will run in the context of the OpenJDK that is a part of the GraalVM distribution. If you want to go the AOT route, you need to process your classes using the native image utility, which is a part of GraalVM distribution. You can install it there, and then it will output you the standalone binary there, and it will run. That slide's supposed to be skipped. Native image in principle, how it works is it takes your application, it takes your Java code, all the bytecode that will ever be run in your application. It takes the JDK class library, right? It takes the runtime components of the virtual machine from the GraalVM project called Substrate VM. So all that code is Java, and then it looks at that code, it initializes that code, it takes a snapshot of the reachable objects, and all of the code that can be run in the application. And then it compiles the code and outputs the heap of that application, writes that into native executable. So you get both the code and the data in memory of the initialized application that is ready to get started and is ready to do business and serve your users as a native executable. And then you take that executable and you throw it into the cloud, and the cloud does its magic and use it. And it's a very efficient way to run your applications in the cloud specifically, because the code is precompiled, doesn't need any compilation at runtime. The code, the data is pre-initialized, so the startup time of your application becomes really a few milliseconds, and those are very good metrics that you want to optimize for. So it does this under the closed world assumption, which is essentially what the closed world assumption is, that when it analyzes your application, when you feed your application to the native image utility, it means that you need to provide access to all the bytecode. Like all the code that will ever run in your application needs to be seen during the analysis time. The analysis is static, so it looks at the code. It doesn't actually execute the code necessarily. So it determines what parts of the application will be run or potentially will be run when you actually start your application. It removes all the unused classes and methods and fields. It removes the compilation facilities or all the infrastructure that deals with the bytecode. Right? It doesn't include the JIT compiler, or it doesn't include the bytecode interpreter, because it compiles all the code at the analysis time. Well, at the image building time, after the analysis. And it applies because it knows that no other code can be possibly loaded into the application. It can do very aggressive optimizations that would not be possible otherwise. For example, right, if you know the class hierarchy and you know that there is like only one particular implementation of an interface, when you call those methods, you know that the class hierarchy cannot change because you cannot load additional classes, and you know there is only one implementation of that particular interface, you can just say like, oh, that method is what I need to run directly, right? Without going through the calling interface and finding which class it actually is. So it allows you some optimizations. Or if you can prove that some things are never null, for example, you can just collapse and optimize away the null checks and so on. So it's very handy to have this closed world assumption. The trade-off there is that there is no loading new classes at runtime, which is very understandable because that was the explicit trade-off. We wanted to see and compile all the code at the build time. So there is no new classes at runtime. And also the dynamic parts of the language need you to provide a configuration. Right? So if you use reflection, or if your dependencies use reflection, or proxies, or you want to use the class loader resources, I don't know, like you serve an image or you serve a JavaScript file, you need to provide configuration for that. The configuration is a JSON file that you can write manually, but the most efficient way is to provide the configuration by running your application on the JVM and using a specific Java agent, right? The Java agent will instrument your code, and it will, whenever you use something that requires configuration, it will remember that and output that configuration for you. So that means that you can prepare that configuration for your particular application by just running it and executing those code paths, which is normally a good idea to do anyway, because you need to do some testing, right? So the workflow becomes run your application on the JVM with the Java agent, execute the code paths, and then take the provided configuration and build the native image. Normally, this is a very good idea to build those on the continuous integration servers. I think this is a great idea then, right? So there is a great support for the GraalVM native images in the ecosystem. One of the frameworks, frameworks that supports that is Helidon. So when you build your Helidon applications, you can very easily convert them to the native image. And I know that the MicroStream, at least some examples of using the MicroStream library for data access work in the GraalVM native image mode. So I would encourage you to explore that for sure, because then you can build those small applications that can be deployed to the serverless very naturally. So let me show you a demo, and I will show a demo of a currently what I want to show is a demo of a Helidon application, of a Helidon quick start application, because I just want to explore. What do I want to explore? I want to explore some runtime characteristics of GraalVM, and I want to show how do you actually do that, right? So I have it pre-configured here. But this was very easy. So I created the quick start Helidon example. You see that? It's supposed to be here. Yes, Helidon quick start. So I will go there, right? And this application, this is a very simple application, right? We can just see here the dependencies, and we can see here the our application is very neatly 3 services, right? So it's a main Helidon application, and let's go there. So I will do what? Source main Java Helidon examples quick start SE main, right? We can see this is the very simple application. We configure this application, and this was the Helidon SE example, right? You can also use Helidon MP, which is the different flavor, and it also works as native image. But here, what I wanted to show is that we configure the web server, we start everything, we create the default configuration config, we do everything, we create the handler, there, and it just runs, right? So this is out of the box thing, right? And of course, what I can do, I can build my application, right? So I will build and I will package my application first here. I don't need Maven package, right? Package. I will package this application. And since you saw before that I was using my GraalVM as a source of the Java executable, right? So when I did Java minus version, right, that was GraalVM. When my Maven used my Java, it also used the GraalVM, and you can see that it built the application properly. And then what I need to do, I just need to Java minus jar, right? Target the current directory, target what's that? Helidon quick start, right? Jar file. It's all very good. It starts, and then I can access this in my browser. Let me access this in the new tab here. In the new tab, right? So what I can do, I can go to that server. I can go to 8080, and then I can greet, right? So you can see the message "Hello world." I can also do like a couple of times that, and this is just my GraalVM running my Java application. Nothing too exciting here. But what we can also do, we can build the same, and we'll build the Maven, what was about -p native, right? We can set up the profile to say that we want to build this with the native image, and this will take a few seconds, right? So this will take maybe a couple of minutes for a small application, because the native image utility, you can see it started running here, building native image. It needs to do a number of tasks. It needs to build the full universe of the classes that will ever be loaded, right? And then it needs to analyze that, and it needs to configure that, and it needs to compile all that. So it will take a couple of minutes. And if you build in Docker, I cannot urge you enough to give it a lot of resources, right? So let me just show you. This is, let me just SSH there again in a different tab. In the different tab, I'm going to SSH to the same server, and you can see that this is a server in the cloud. In the cloud here, Oracle is a cloud provider, so I'm using that HTOP. I'm using that to my advantage. What you can see here, currently we are running the native image build, And this is quite a powerful machine. It's not like super powerful. It's not a supercomputer, but this is something that has 16 threads, 16 CPUs, right? And it has quite a bit of memory. And you could see that if I didn't configure any resource consumption. You can do that, but by default, native image would use all the available resources to speed it up. And you could see that it parallelized its workload quite a bit and used quite a bit of memory as well. So if you can build it on a powerful machine, your experience will be swifter, right? So, and you can see it used what, a little bit over a minute, and it used like 5 GB of RAM to build this image. So if you run in Docker by default on the Mac, for example, I think Docker gets access to 2 GB of RAM, which means it will start swapping and you will not see the end of it. So give it more resources, give it a few CPU, build it on a cloud machine. Doesn't have to be like, I'm not here to advertise the cloud, right? So on any cloud, just like get yourself a machine with a few CPU and run it, right? But now what we have now is the what was that? The executable here, right? So this is what I mean by the native compilation, right? We have a native executable, which is linked to the operating system libraries, right? It doesn't depend on the JVM. If we do file this, right? If we do, oh no, we do file, and then we do the same path, right? We do the file, the same path. You can see that this is an ELF executable. It's reasonably small. It's like 35 megabytes. You can compress it down further with UPX, which is the compression thing for the executables, right? It kind of zips them, gzips them, which is kind of handy. And it trades some startup time for the size here. But 35 megabytes is not that large, right? You can work with this. So, and now this executable, right? It starts very, very nicely, right? I can run it. I need the path, not the size, right? I can run it and it starts really fast. I bet you didn't even see how fast that was, right? Boom, didn't see that. Like it starts in milliseconds. Doesn't, surprisingly, doesn't tell me how fast it starts, right? But you can see that it still works here. So this is the same server and it connects and talks to that. It also exposes metrics by default, right? So I think it's using micrometer or like some metrics library. So you can definitely do some metrics there and I don't know, send it somewhere. So you can see there, if we do, let me just make it smaller a little bit. And let me just make a few requests here. So you will see, and we'll see vendor request count total here increase every time I do a refresh. Right? So now it's at 20 and you can see here, now it's 24 and we refresh and it goes higher, right? So actually like it works, metrics work, and you can build fully functional applications with this. And it's very nice and neat. I also have an example of native image with MicroStream, but I will not show it here because we would like to save a few minutes to talk about Polyglot, right? So native image, in short, let me just come back here and tell you what I wanted to tell you. Native image gives you a very good opportunity where you can take your Java application and deploy it to the cloud and make use of the existing Java ecosystem with some configuration that you need to do and some understanding of native image does, so you can use it efficiently. But you can put it in the cloud and you get the runtime characteristics. Oh, let me show you. You get the runtime characteristics of a native application, right? So if we do target Helidon quick start SE, right, and run this. Let me do the user bean time, right? I want to time it but I want just to do the -v option because it will record me the RAM usage of this, right? So I will do this, and I will send 2 requests, right? We'll send 2 requests here, and we'll stop this, right? You can see that the time now timed this, right? And of course, we sent 2 requests manually, and I waited a few seconds, so the time is not what's interesting. What is interesting is the maximum resident set size here, which is the total memory that my application was using. It was 50 megabytes to set up the microservice, to run it, to run the HTTP, to respond to some requests, and actually to enable and run the metrics here, so the request to the metrics, and all that used less than 50 megabytes of RAM. So that means that you can put that 35 megabyte application into very simple and very almost empty Docker image and run it in the cloud using very small instances, right? Even on the serverless, it will behave nicely and give you the runtime performance of, I don't know, of a native application written, for example, in Go, which is a very interesting use case. So you should try that, right? That's the native image. You can also build the shared library of your application, right? Of a part of your application, a shared library, and use that from the native program. But this is a bit more advanced use case that is possible, but maybe you should explore the simpler ones first. So native image can give you the performance boost in the cloud setting. And then there is Polyglot. And there are a number of ways how you can do Polyglot on GraalVM. And just recently, so we have a blog, a company blog, right? A team blog at medium.com/GraalVM. And I just wanted to show you one blog post there that my friend Michael has wrote about Neo4j, right? And he wrote, and you can just go on media.com/GraalVM and read the blog post. I'm sure they're all very good, but he wrote a blog post about the many ways of polyglot programming with GraalVM, which is very, very interesting because normally what we would talk about is how GraalVM can run different languages. So that means GraalVM can run multiple languages within the same application. I'm sorry. So, but that's not necessarily true. You don't need to mix all the ecosystems in the same application to make use of the polyglot features. What you also can do is just to use, like, say, for example, 2 languages, or to expose one language libraries to the others. So this is what Michael explored in this blog post, and this is what I want to explore very briefly in the last few minutes. So this is how the ecosystem of the languages that run on GraalVM look like. When we run our application, right? When we run our application, this would normally be a Java application, and it will run on Java Hotspot VM, on the JVM, and this is the JVM implementation from the OpenJDK project. On GraalVM, in the GraalVM distributions, it will plug the GraalVM JIT compiler as a top-tier JIT into this Hotspot VM, right? And it does so through the JVM CI interface, which was added to Java 9 using in a JEP like a few years back when Java 9 was being developed, right? And so through that, you can run all the Java applications, right? You can run your applications in Clojure and Kotlin and Groovy and Scala and Ceylon and others. For other languages, you need to additional support, right? So there is no translation from other languages to Java bytecode. So it doesn't run directly on the JVM. You actually, how it works, you create an interpreter for the language. And then the interpreter is written in Java. And then it starts interpreting the program in language. And then it gets compiled at runtime. It sort of fuses the target program and the interpreter code together, creates a very large graph for the optimization purposes, and then passes that graph to the GraalVM JIT compiler, which then can compile that to machine code. So there is no intermediate representation of your, say, JavaScript program using the JVM bytecode. Right. So, and this is very simple, right? You run the bytecode, or you write your application code through the interpreter that is written in Java, that gets compiled at runtime. And even we have the LLVM bitcode interpreter, so we can run native applications written in C and C++. And we currently mostly are using that to run the native extensions for Ruby and Python. But you can also run like larger native applications. For example, we can definitely run Doom, or we can run we can run Quake, I think, or some other interesting stuff. So yeah, that's how it works. And then there are 3 ways that Michael explores in his blog post as the polyglot, and I think this is very interesting to explore. Right, so it's very interesting to explore because, for example, the MicroStream is a library that you can use to connect to the database for your persistence, and it can be used in a very similar fashion to Neo4j here, for example. So one way of Polyglot is to run your Java application from other languages. So you can use, for example, GraalVM to run your JavaScript application and use MicroStream to connect to the database, or you can use it to run a Python application and can use MicroStream to connect to the database. That is one way. And the other way is more interesting. If you have a Java application that can be enhanced with some user-defined code. So for Neo4j, that is the custom stored procedures that you can run in the database, and the Neo4j is a Java program, so you can run that on GraalVM, and then you can execute the user code that is specified as a JavaScript program inside that application. So if you, for example, building a Halidon application for the backend, and you want some configuration that users can do, like a third-party configuration, like a third-party apps for your base app, right? You can use GraalVM to run those third-party code snippets in JavaScript or Python within your Java application. So that is the second part. And the third part is absolutely mind-blowing to me, at least. What you can do, you can compile your Java library as a shared library, like native shared library, right? And then you can use that shared library from native or other applications, which here would mean in the hackathon terms, what it could mean that you can maybe compile the Java code that is using MicroStream driver, like the library, and compile that in a shared library and use that shared library from other applications where it might be very interesting, right? And you can connect to the database through that. So all those 3 use cases I explored in that blog post, which is what I recommend you to go through and read and think whether the app, whether that is one of those will inspire you to explore something for the hackathon. Because I think out of all the advantages that GraalVM gives you, right, performance or cloud friendliness and Polyglot, I think Polyglot is one that gives you the most flexibility and freedom in what you can build that no one else thought is possible to be built, right? So you can try GraalVM Enterprise Edition if you want, and it will give you better performance. So I actually, since you're evaluating things and trying out things, I would encourage you to try it. But you also can use the standalone, the GraalVM open source GraalVM Community Edition distribution and bits. And in any case, I would encourage you to join the Slack workspace for GraalVM, where you can ask questions. I know that there's a forum that you can also participate in. But if you have, like, in the future specifically, if you have the individual GraalVM related questions, I think that Slack workspace is what you should try to join to ask them. Right, so this is, and I don't have more slides. I have like 6 minutes, so I think this is the best time to just kind of start wrapping it up. And if you have any questions, I would be absolutely happy to answer. I also, if you don't have questions, I do have some other examples that I can run and show, but I think it is less productive than answering questions. Right, so Zoom obviously doesn't run GraalVM. I don't know, maybe they do, right? Zoom is a big company, right? Maybe somewhere they run GraalVM or evaluate GraalVM. But if you work for Zoom and you experiment with GraalVM, please come to me. I would be absolutely happy to hear about that, and let's chat. So Jimmy Bond asks, so that's super secure then? You can't exploit serialization on GraalVM because this requires to feed new classes to the JVM, right? This is very interesting, right? So that is one of the implications that the native image compilation gives you, is the enhanced security, right? I don't think I can tell you that your application will be secure, that no one can guarantee that, right? But think about that. There is no loading new classes into the application. That means that the certain classes of vulnerabilities are just not present there. Like, for example, the problems with deserialization, because serialization is not supported in that sense in the GraalVM native image, right? It also removes the actual code that your Java application pulls in, right? You have, like, how many of you actually can tell me that you know exactly what transitive dependencies you are ending up with, right? And what versions of the transitive dependencies you're ending up with, and whether they are all patched to be like to the latest versions and are like secure or not. If there is code that you are not actually using, like if your application is not using it, native image will remove that code from the final executable. So what it will do, it will determine exactly on the class and actually class member level what needs to stay or not. So it can remove the fields, it can remove the methods that you're actually not using. And less code means less security vulnerabilities. At least that's the general consensus. So it also doesn't include like the JIT compilation, right? So everything is precompiled. So you can run it in, so it can run it with, the environments where you don't have the executable memory. So where you can't run with the JIT, right? Which is very cool. So I know that there are some attempts to run GraalVM native image based applications on iOS, for example, which could be very interesting, but maybe less, like more interesting in general rather than in this hackathon sense. Like I don't think your iOS app requires, like, for example, Helidon, right? Unless you're building like a backend story for, though you can have Helidon and you can maybe have the HTTP client there as a client, which could be very interesting, right? And then you can use CDI to configure things and like inject the beans into things, right? So I digress, right? So yes, you need to, like, you should kind of revisit your security model because native images can change that significantly, right? So Corbinian asks, it would be very interesting to see how fast the native image of MicroStream and GraalVM could be. Please show. Yeah, I have that example somewhere here. I have the link to that example. It's not set up. I didn't set it up actually properly, so it will take me a few minutes. We can try doing that live after the questions if there is still interest. I can actually try it live. We'll see whether it works or not. I didn't prepare that myself, so there could be version mismatches or anything. So when we will stop recording, I will give it a try. Okay. And it's also, so you have to understand. So there is this one particular bit that I want to cover here. Let me go back here. Am I still sharing my screen? I'm not sharing my screen. I am showing my screen, right? So let's come back here, right? In terms of the raw performance after everything is warmed up, right? After you gave your JVM enough resources to engage the JIT and profile your code, and you've run with enough profile to determine which code paths are hot and which needs to be compiled. JIT is very, very efficient at making code run fast, right? So if you talk about pure throughput capabilities, right, how fast it is, then probably running on GraalVM in the JIT mode can show you better numbers in terms of how fast it is, right? How many times you can execute a certain operation within the unit of time, right? So how many records can you store into the database using MicroStream in a unit of time? Probably the JIT will show you absolutely the top absolute numbers, right? So native image pre-compiles the code ahead of time, right? And it does it for all code, right? So all code is compiled there, nothing is interpreted. But if we compare the warmed up JIT, it also compiles the code at runtime, right? It still compiles. So the compiled code is what we use to measure the speed of execution, right? And AUT doesn't have access to some very nice features of the JIT compilation, particularly speculation. And well, it speculates a little bit, but it cannot de-optimize and then recompile again. So that means that it can sometimes, it cannot give you the same level of optimization as the warmed up JIT. Though, like if you use, like you can use the profile guided optimization where you collect the profile and then feed that to the native image utility, and it will be faster than the normal native image. And it will get very close to the warmed up JIT, depending on certain workloads and so on. But it's still, the JIT has the superiority there. However, native image will be very fast out of the box, right? So until your JVM warms up, native image can absolutely eat it for breakfast, right? And also if you package it into constrained environments, there might not be enough resources to run with all the facilities that the JVM provides you out of the box, right? So for example, JIT will need to take some space, memory, and some CPU, right? Also, like for example, if you run with a more sophisticated garbage collection like G1GC by default in Java 11, right? You don't have to, like, it has to run concurrently with your application, right? So if you run in a container with like half a CPU, and you need like a CPU or a few threads for the GC, and you need a few threads for the JIT, maybe those threads are better spent doing useful work, business work. So pre-compiling code ahead of time is very interesting there for smaller runtime environments. So that is just a comment about the fast native images. But like, I'm pretty sure that like if you just measure the time that it takes to boot up the application, run the native image, save some data or read some data from the database, and then kind of stop working, right? It's like kill itself, like finish the program, finish the execution. That's the correct phrasing. And then finish the execution. Then it will be milliseconds, right? Maybe, I don't know, like probably it will be dominated by going to the database. Right, Ronald is asking, will there be any Java 8 plus source code compatible to be compiled as native image with GraalVM, or is there any particular case when your classic source code would not work? Right, so yes, so Java 8 plus. Java 8 plus works in the sense that Java 8 works and Java 11 works because we have distributions based on Java 8 and 11. There are a few areas where you need to there are some particular limitations or current technological limitations that you are doing for that you're going to hit. One of them is, for example, the serialization is not supported on GraalVM because at runtime there is no deserialization serialization. So you need to work around that bit and maybe provide your own like serialization to JSON or something. So Java serialization will not work. There are some like advanced use cases like using method handles dynamically by constructing method handle chains at runtime, right? So GraalVM native image currently can handle native method handle calls that resolve to a single method execution, and we're working on improving this. But this is the case. There's also, you could stumble on something with var handles, and then this is just pure like language things, right? And then there are some things, JVM-TI, Java Virtual Machine tooling interface things do not work because they require bytecode things at the runtime, which there is no bytecode, right? So you need to be aware of those things, and there is documentation. You can find that on the graalvm.org or on the repositories. This is one part, but this is like a small part, right? Like usually large classes of applications work, and we have tons of examples. Actually, the GraalVM compiler itself, right? It's a Java application. When you download GraalVM distribution, what runs is actually the native image, the shared library that is created by using native image on the GraalVM compiler, right? And then when you run that Java command here, this, right? Java minus version, right? This, well, maybe this didn't because it didn't initialize the JIT maybe, but what it did, it ran Java, it ran the hotspot, and it ran the shared library of the JIT compiler compiled with native image from the Java source code of the GraalVM compiler, right? So very many applications work like that. And what is more important is that you need to understand that the new life cycle of the native image, that there is the build phase, right? Well, you build your application, and the runtime phase where you run your application, because that introduces some interesting things, because some classes can get pre-initialized and written out in the heap, right? So for example, if you use some random instances, right, you can get pre-initialized and bake it in if you are not careful, right? And then your random will return 4 until the end of times, which is probably not what you want. You can start some threads, for example, right? Or put some file handles during the build time. And those cannot be reasonably saved until the runtime, because that could be on a different machine or a different Docker container. You cannot preserve a running thread or like an open file. So if you have some code where classes get loaded and then in static initializers, for example, they open some files to do some random things, you can have some challenges with those. There are workarounds and there is compilation there, but that is probably more realistic source of obstacles that you will hit when compiling your application as native image. So it's better to use libraries and frameworks that do have support and test. Sometimes you cannot not use like new code, because sometimes you are actually writing those libraries yourself, right? Yes, so then there are ways to do that. And the like reflection and everything, what many people say, like it's a kind of complex part, is actually very neatly resolved with the Java agent, so it's not a problem almost universally. Right, so I hope that provided some answer. Christian Lance, supporting so many languages seems a bit of overkill. Is it all about to compete with the speed of Golang? Wouldn't it be easier to just use all the manpower and focus only on Java, Kotlin, Scala, Groovy, and so on, and make the GraalVM even more faster than it already is? There are a number of questions, right? And the main question here is about the priorities, I think, right? So the priorities, there are different people who are writing the compiler and improving the compiler, and people who are writing and improving the language support, right? So there are different sub projects within GraalVM. There are different people responsible for that. So it might seem that like for some particular use cases, for example, the compiler is what you want, right? And only the improvement to compiler makes sense to you, right? Or maybe indeed you want to use it to compete with the speed of the Golang applications without leaving the comfort of the JVM ecosystem, right? If you have developers who are experienced in writing applications for that use Helidon and MicroStream, right? And they think that this is a great combination. Your alternatives are like, and you want to be like very cloud friendly, right? Your alternatives are either teach them Golang or hire other people, which is sort of, I mean, I don't think this is an ideal solution, right? Or you can use native image and continue using the team that you have and trust and technologies that you know and trust. So that is maybe then you would like, oh, GraalVM, you can try to like, you will like personally to you, GraalVM will get reduced to the native image technology, right? Which heavily depends on the compiler, because the compiler is what compiles your code. So better compiler will mean faster executables, but you will still kind of get only the benefits of one particular example, right? But for the team and for the GraalVM as a project, all of those pillars are very important. Actually, there is also a fourth one, which is sort of a little bit of Polyglot, but also others, which is the tooling, right? The tooling is very, very important. The tooling that works across all the languages, across all the Polyglot languages, the compiler that is very good for compiling your Java application and being used as a JIT compiler, and to compile your Java applications ahead of time, and also very good at optimizing the interpreter for the JavaScript, for example. There is a very large benefit of having the runtime for multiple languages, because you reuse almost all the runtime bits, right? You get the support for the JVM as a platform, you get the support for the compiler, state of the art, the best compiler that you can probably get for the language. You get support for the GC, right? So if you want an implementation of language, I think this is excellent, right? For example, there was this an attempt at writing a PHP implementation on GraalVM, and that was some student work. And they didn't write the whole PHP, but just enough to run this, like the benchmarking game benchmarks, right? You know, where people supply the implementations of like small programs, and they just did like some, like it was a short time project, right? It wasn't like an extensive thing. And then they showed the results where their implementation beats PHP like 7-8 times faster, right? So that's like 800% performance improvement over the existing PHP by spending like a few months working on PHP implementation in GraalVM, right? And that was a third-party person, obviously a great developer, right? But not someone who is intimately aware of the like particular implementation, how to use GraalVM the most efficiently, right? And I think that's a great win. So Polyglot is important, the compiler is important, the native image is important. You can pick and choose, and this hackathon probably provides you a very great playground to think about like how you can use GraalVM, right? And so there is a special GraalVM award for using, right, GraalVM in the hackathon. And there is, I don't think that there is currently like a decision which like for me, it could be any of those, right? It just needs, like, if your application, if your entry shows a nice and interesting use of GraalVM, that's all that's required, right? Whether it's for the cloud, the matching speed of Golang, or being better than Golang, or Polyglot, or something, right? It's up to you, because GraalVM is about giving you options, right? Hope this answers. but also the main idea is that there are different people. So, and their skill is not necessarily transferable one-to-one. Frank asks, with GraalVM, no obfuscator is needed anymore. That is sort of correct, right? Because you can here, I'm still sharing my screen, right? Right, I'm still sharing my screen. So what I can do, ls what target, right? What I can do strings target target. What was the application thing, right? Helidon quick start C, and I will grep, for example, GraalVM. Right, you can see that in that native application there are, well, obviously the strings are, some strings are preserved, right? So it could be, maybe it could be version, right? Version, right? A bunch of versions there. So you can get some information out of that executable, right? Right. What I was trying to say, right? So there could be some information in there. So you might still want to maybe obfuscate it beforehand for those particular bits, like to shuffle strings and whatnot. But yeah, it's a binary file. So if you can I open it? Does anyone know if I can open it? If I cut it, right? Oh, this would be interesting. Target. I never tried this, so this is new now. Damn it. Binary. It's a binary file. It's a binary file. You will get hacks there, right? But so yeah, hope this answers. Right, Mario is asking, is there any chance of improving AOT compiler to get it near the throughput of the JIT? Yes, and actually this is in the works. So some of the improvements will definitely be the enterprise edition only. But some of the improvements will get into, like, the community edition is getting better at it all the time as well. One way to get to the near JIT throughput is definitely to use the profile guided optimizations, right? Because depending on the workload, one of the, like, very often, right, your code, like, all code is like a series of if-else branches, right? Like you're writing conditionals all the time. It's just like different syntax. And then sometimes if you have the probabilities, if you have the profile that tells you which branch you take more often, right? Which branch is used way more often. And when one branch dominates the other very, very much, you can definitely compile that particular branch better, right? So you have the profile. You can spend, for example, more time on optimizing the likely code path. And you can also devote more code size for optimizing the likely code path, right? And then your unlikely code path, your cold path, will get less attention and less space, right? So you cannot compile everything to the best of your ability. There has to be a trade-off somewhere there. So profile guided optimizations, get it near the throughput of the JIT, particularly if you're talking about less capable JITs, right? So since you're using the GraalVM JIT to GraalVM compiler to compile the ahead of time, right? Probably the GraalVM compiler will still be a little bit faster, depending on the workload, but maybe some not as sophisticated JITs, ahead of time compilation can definitely maybe get closer to that. But that is the project that requires engineering work and time, right? So we're working on that, but we'll see where it gets. Like, it depends on the particular workload as well, right? So Ronald, if the classic Java serialization isn't supported, how about that serialization that MicroStream uses? As far as I know, they have an own implementation of serialization. So that is not the question to me. I don't particularly know the details of the MicroStream serialization. But think about this, right? The default Java serialization is not supported. That doesn't mean that you cannot serialize objects yourself, right? Even here, right? I showed you an application. I showed you an application that here. Wait, I will start the application again. Right. La 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 la. Right, and then we'll do the bench, and the thing here is 8080 greeting. I think it needs to greet, no primes, greet. Was it greet? Yeah, greet. Look, right. So what happened here is that this code, this is not the string that we output. We output like our code, like our Java code there probably outputs like an object or something, right? And then that object gets serialized to JSON, right? So you can totally have serialization working on GraalVM native image. And deserialization, you can get that JSON and construct your objects. You need to construct the objects that you need to provide that code, and that is not the you need to say, yeah, right? So you can serialize and deserialize objects. You just cannot use the Java serialization, right? So as far as I know, the MicroStream library works in the native image mode. So that means that the serialization works, right? So you can save it. You can technically, yeah, you can say like if you use MicroStream serialization as a library just for serialization, you can use that with GraalVM native image, right? In other applications as well. Yeah, sort of like you can, yeah. Another example could be like what? JSON-B or some JSON library, right? If you like semantically it would be similar, right? Right. La la la. You said with GraalVM, a MicroStream app would be even faster. MicroStream guys say GraalVM native image together we have MicroStream, and Oracle DB is the fastest combination for database development with Java ever. Would you agree? MicroStream is actually brand new. Has Oracle already recognized the power of MicroStream together with Oracle DB? Right. So I cannot like first I don't speak on behalf of Oracle. I cannot speak on behalf of Oracle. Back here. Right. And I don't know the details of the MicroStream implementation, right? It could be like, it could be that it works with Oracle database. It could be that it works really well. Unfortunately, I'm not the person to answer that question. I think maybe Marcus can comment on that, or maybe there's a session in the agenda that could talk about that particular aspect of that.
Yes, tomorrow is first live coding session. There we show how it works, how to build a database application running on Oracle. And we also have a performance demo that proves how fast MicroStream is in comparison to JPA, for instance, with Hibernate, and database access to Oracle databases with MicroStream up to 1,000 times faster every single query. And we show this in the live coding session tomorrow.
Does native image run on ARM? Yes, it does. So there are currently ARM 64-bit distribution for GraalVM available. Linux only, of course, because one of the underlying platforms for non-Linux on ARM is that there is no JDK on non-Linux on ARM as of currently in the upstream for Java 8 and 11, as far as I know, right? So, which is what we built into the GraalVM distributions, right? So you can run on ARM, you can run on the cloud ARM machines. You can run on Raspberry Pi. You can Google, there are examples of running Java applications on, say, Raspberry, like native image of the Java application running on the Raspberry Pi, which is obviously they use GraalVM for that. So yes, it does work on ARM. M1, as far as I know, it doesn't. I mean, like it can work through the, what is that, Rosetta, or like when they take Intel code and run it on ARM. I haven't tried. I don't have an I don't have like Apple M1, right? Like if anyone wants to like ship me a Mac Mini, I would try it in an instance, right? But I don't have access to that. I like, so if you ask whether you can build a native image for Mac OS, like a normal Intel based native image on Mac OS and run it on Apple M1, then through Rosetta it probably works, right? But there is no M1. There is no Java 8 or 11 JDK in the upstream projects, right? In the 8U and 11U that work on Apple M1 as the ARM, like normal ARM. Hope that answers, right? If you, yeah. So it does work on 64-bit ARM on Linux, and probably like a short answer, it doesn't work on Apple M1 unless in the list compatibility mode with Rosetta. Do we have any more questions? That's a good one, actually. ARM is very important, and I think we will try to increase the amount of attention that we put into the ARM builds in the future, because it's a very interesting and platform, and it gets more and more important, right? There are allegedly people working on the JDK on Windows on ARM and JDK on Mac OS on ARM, right? And even if the main users for those are developers, I personally think that this is a very important demographic that that projects need to cater to. So yeah, I mean, I don't decide the fate of GraalVM, right? I don't assign resources, but I think that it's an important thing. So I would be very happy to see increased support for that, which I also can tell that it's happening, right? As we are working on that. Sorry, I'm rambling now because there are no more questions. Right. No more questions. Very good. Oh, wow. I clicked on the random. Go away. Clicked on the random link and started opening. Excellent. So just to wrap it up, I recommend you and I urge you to explore GraalVM. It works with Helidon. It works with MicroStream. Think about the possibilities of combining that with maybe other languages or other some libraries in the other language ecosystems, because I think that's how you build the most unique and the most incredible applications. So, which is kind of sort of the point of a hackathon, right? You want to stand out, right? And for that, you might as well use all the chances. Yeah, but for the normal Java developer work, just maybe you can use less flashy, just better performance bits.
This was really a great presentation, and you answered lots of questions and was very detailed, really fantastic. And I think we have learned a lot of GraalVM today. It was really great to have you. Thank you, Oleg.
Thank you very much. It was a pleasure to be here.
Great. And all of you who want to join the hackathon, you can sign in for the hackathon, play around with Helidon, GraalVM, and MicroStream together. Tomorrow we have a very interesting session about MicroStream getting started coding. So no more slides. We will jump directly into the code with Christian. And then don't miss our weekly Q&A session thank you everybody for joining and for your time, and goodbye.